Hello everyone. In this video, I'll show you how to use the DWSIM software to model a heterogeneous reactor. As we know, this is the design equation for a packed bed reactor. It is an ordinary differential equation. To solve, we can solve this equation either to find the weight required to achieve a certain conversion or to calculate the conversion at a given weight. The information we need to know are the operational parameters in terms of the composition of the feed, temperature, pressure, as well as the rate equation. This is the question that we need to do using the DWSIM software. Hydrogenation of toluene into benzene and methane is to be carried out in a packed bed reactor. This is the reaction. Toluene plus hydrogen gives benzene and methane over an aluminum catalyst. The total molar feed rate is 1 kilomole per hour, and the reactor is to be operated isothermally at 640 at a given pressure of 40. The mole consists of 30% molar percentage of toluene, 45 of hydrogen, 25 of nitrogen, which is an inert. So nitrogen does not participate in this reaction. Hydrogen is to be used in excess in order to prevent poisoning of the catalyst. This is the bulk density, or the loading fraction of the catalyst is 400 kilogram per cubic meter. This is the diameter of the particles of the catalyst, 2 millimeter, and the body fraction in the catalyst is 4. The reactor volume is 0.0157 cubic meter. The length is 2. And the rate of the equation is given in a numerator-denominator format with the value of K. This is the value of K with this unit. And these are the adsorption constant for benzene, the adsorption constant for toluene. So in the DWSIM software, we need to open a new steady-state simulation. And write all the compounds that appears in my question. The first one is nitrogen, then the reactant, which is our toluene, hydrogen, benzene, and finally methane. Next, here we need to choose the system of the units, the thermodynamic package. The thermodynamic package. We can go for any one of them, as long as they are consistent with the thermodynamic properties of the selected compounds. Our system is quite simple, so we could go with the Swab-Bradley-Quanch equation. Click Add, then Next. We need to choose the system of the unit. When you choose the system of the unit, it's better if the units are consistent with what I was given. For example, I was given the unit of molar flow rate in kilomole per hour, the unit of temperature in Celsius, the unit of pressure in bar. So the SI unit is not good for me, so I have to choose another system of unit, which happens to be C5. In the C5 system of units, the molar flow rate is given in kilomole per hour, the temperature in Celsius, the pressure in bar. Of course, you can create your own system of units and make it consistent with the values that you have in the question. Next, you click Finish. You go back to Setting. From Setting, choose Reaction. Then click Add a Reaction. Go to Heterogeneous Catalysis. In the Heterogeneous Catalysis, we need to specify the reaction. Nitrogen does not participate in the reaction. However, everything else does. Toluene is the basis compound. Here we need to write the stoichiometry. If a species appears on the reactant side, its stoichiometry is negative. If it's appears on the product side, then its stoichiometry is positive. Toluene and hydrogen are both reactants, so both of them are -1, and benzene is 1, methane is 1. This is the let's make sure my equation is balanced. This is the equation. Next, we need to choose the basis of the compound, which is partial pressure, and the phase. It is a gas phase reaction, so choose vapor. So here we need to write the rate of the equation, and DWSIM always writes the rate of the equation for a catalyzed reaction based on a numerator and denominator format. For our question, it's already given in a numerator-denominator format. If it's not, then you need to convert it into this format. The second thing is, in DWSIM, we cannot write the name of the species directly, but its number. For example, toluenes appear first, and it is a reactant, so it is R1. Hydrogen is R2, it is the second reactant. Benzene, it's P1, it's the first product. Methane is P2, it is the second product. So in the numerator, as given in the question, it is 0.087 times R1 times R2. In the denominator, it's basically 1 plus the equilibrium constant for benzene, 1.39, and benzene is basically P2, plus the equilibrium constant for toluene, 1.38, times the equilibrium times the pressure of toluene. Toluene is R1, it is the first reactant. So the amount of the units, they are in bar, as given in the question. And the rate of the unit, it has to be consistent with what the question gave me. It's small, kilogram, minute. So I have to look for this unit, which is this one. It's small, kilogram, minute. So I think everything has now been entered in the software. Click OK. Go to the DWSIM, so close this window. In the DWSIM software, choose a material stream. Click on this material stream. Now we need to change the condition. In the input data stream conditions, the temperature is 640. Click enter. Then the pressure is 40 bar. The molar flow rate is 1 kmol per hour. We don't need to write the mass flow because it will be calculated automatically. And the compound amount, these are the mole fraction for toluene. Sorry, for nitrogen, it was 0.3. For toluene, it was 0.25. For hydrogen, it was 0.45. For benzene, it is 0. For methane, it is 0. They appears on the product side. Then click accept. Change the name. Change this name into feed. Sorry, I think for nitrogen it was 0.25. For toluene it was 0.3. For hydrogen it was 0.45. That's correct. So click accept, and the total is 1. So the summation of the mole fractions is 1. So close this window. Then go to reactor, choose a plug flow reactor. Click on the plug flow reactor. The first thing is to, from the calculation parameters, go to general, then the calculation mode is isothermal. The dimensions, I was given the volume of the reactor as 0.0157. The length is 2. The length is 2. Then let's go to the, you can see the diameter is calculated automatically because the volume of a plug flow reactor is basically the volume of a cylinder. For the catalyst information, the catalyst loading was given as 400. The catalyst particle diameter, it was given as 2. The void fraction is 0.4. Let's make sure the dimension is correctly entered. That's okay. Then click on the plug flow reactor, and now we need to do the connection. For the inlet stream is the feed that we have specified. The outlet streams, click create and connect. The energy stream, click create and connect. I think we have entered everything successfully. Now click on solve. It should only take a few seconds to complete. Now calculation are finished. Click on the plug flow reactors, general, go to reactions, then conversion. So at these conditions, the given conversion for toluene is 66.9, and you can also view the concentration profile. You can open it in a new window. And this is the concentration of benzene. This is the concentration of methane. Basically, they should appear in the same in the same range. So the concentration of benzene is equal to that of methane. The concentration of both of toluene and hydrogen decreases with the length of the reactor as expected. The temperature is constant and there is a very minimal pressure drop. You can also view if you click on the outlet stream, you can view the mole fraction of toluene. The mole fraction of toluene has decreased from 30% to 10% because 60. I think we calculate this should be consistent with the conversion that we have calculated. Thank you so much.